Okay, chapter 7, chapter 7, chapter 2, AP chemistry. This is naming compounds. Very easy. Very easy, actually. Let's fly through it, all right? So these are some quick notes that you should know. The first thing is Avogadro's hypothesis. At the same temperature and pressure, equal volumes of different gases have the same number of particles, and that is what 6.023 times 10 to the power of 23, right? This is just يعني هيك. Okay, radioactivity, you should know that radioactivity particles decay to form different nuclei. What's alpha, beta, and gamma? An alpha particle is He24. A beta particle is an electron, and it actually has a mass of 0, charge of -1. Sorry, it's the other way around. -1, 0. Gamma rays are 0, 0. They have 0 mass, 0 energy, 0 charge. Okay, these are just take to know. You don't really use them here. Like from what I've seen, you don't use them. All right. Anyways, over here, what's Rutherford's nuclear atom? Who is Rutherford? Rutherford was a physicist, and basically he was playing around with the atoms, and he got like a few conclusions. And basically, he said that an atom. He found that then he basically figured out that the nucleus, okay, is very small compared to the rest of the atom. Okay, that's pretty much it. You can read this. An atom with a dense nucleus is it's smaller than the rest of the atom. Anyways, that's what this means. The radius, the nuclear radius, is the whole atom. That's actually way bigger than. Sorry, what? No. The nuclear radius is the radius over here of the nucleus, and he figured out that that's way smaller than the actual radius of the atom. Okay, there's a big difference. Anyways, you don't need to know this, and it's like the questions here, don't ask them. Isotopes, what are isotopes? Everybody knows what isotope is. You can pause and read if you want. All atoms are composed of the same components, but they have different chemical properties. This is because the number and arrangement of electrons is different. Okay, so if, and you're going to see this a lot, whether you're doing A-level chemistry or AP chemistry, they ask you what's the reason behind why these two atoms have different properties? And that's simply because they have a different electron arrangement. Okay, that's it. Okay, you may see questions like that. Naming a binary ionic compound. How do you name a binary ionic compound? Okay, whenever you have an ionic compound, it's made out of a cation and an anion, right? So let's just call this mine. Now these two form to make this compound Xz. Now here's the thing, how do you name this compound Xz? It's very easy. Okay, the cation is given the name of the metal, of the element. So مثلا NaCl, it's actually, I think everybody knows that it's called sodium chloride. Okay, so sodium chloride. So as you can see, the metal's name, and then the anion ends with IDE. Okay, now if you had a transition metal, مثلا Fe2O3. Iron is a transition metal. Over here we're using Fe3+. How do you know it's Fe3+? Because you look at the charge of oxygen. Okay, so I cut off, but I think I was giving the example of Fe2O3, how iron in this case is Fe3+, right? How do you know it's Fe3+? Because it's O3. The oxygen takes the oxidation state of Fe. So since it's 3, that means the iron here is Fe3+. So naming this here, you'd have to say iron oxide, right? And that's the name, iron oxide. But this is wrong. Why? Because you have a transition metal. When you're working with a transition metal, you have to actually say the oxidation state of that transition metal, okay? So in this case, you would say iron 3 in brackets oxide. Okay, now it has to be in a Roman number, okay? But it follows the same rules. Very easy. Now, are there any exceptions of some transition metals? Any examples I can give you? Now I'm going to give you these. This the notes my teacher gave me. The most common ones, I'll tell you what they are. So let me open board and let's go to there. So first thing is Hg, which is mercury, 2, and you have Hg. It exists sometimes as diatomic and monatomic. When it exists as diatomic, we say it's mercury 1. Okay, and when it's 1 monoatomic, it's the opposite, it's mercury 2. Okay, I'll continue with the rest. The rest are pretty straightforward. Mercury is the only hard one. So see how mercury, it changes not with the charge, it changes with the, they're both 2 plus, by the way, but it changes with the atomicity, as you can see here. Okay, the rest are pretty straightforward, like Cu2 plus and Cu3 plus. Chromium, Cr2 plus, Cr3 plus. These, don't memorize these, but the main one you need to memorize is this. Okay, iron, I'm sure you guys are familiar with iron. You have lead, which is 2 plus, and there's also 4 plus. These are some examples that you may see. Tin, Sn. You also have gold, which is Au. These are just some examples of transition metals that have different oxidation states. So that being said, let's move on. So this is, I gave you this example because you're going to see the mercury question a lot. Okay, so here it's Hg is mercury, by the way. Okay, so it's mercury chloride, right? You would say it's mercury chloride. But as you know, mercury is one of our exceptions. It's actually the most important exception, because like this is the one that actually stands out. I don't think mercury also is a transition metal. It's part of the non-metal. Wait, no, maybe it is. I don't know. But mercury stands out. You should know that mercury is the big exception. Okay, it's the most important one. Okay, so we can't just say mercury since it has 2 different oxidation states. Not actually, it has 2 different like names. How do we know which is which? We take a look at the atomicity for mercury. It's 2. What did we say in our rule? Hg2, what's that called? It's mercury 1. So we say you have to say mercury 1. Let me get my pen. There you go. Okay. What is the formula of chromium 3 oxide? Chromium 3 oxide. So Cr3 plus, and oxide is 2 minus, right? So crisscross, and you're gonna get Cr2O3. You cross. You take this down here, I take this down here. Okay. Now we're done with this easy naming stuff. Very easy. Oxyanions. Okay, what's an oxyanion? Okay, should we know that anions are these negatively charged atoms, right? Now, when I say oxy, what does that mean I have in it? Oxygen. Very easy. So it's any anion containing oxygens. So the most famous example is CO3 2 minus. You also have NO3 minus. You have NO. Let's see. No. You can have. I can't really think. OH minus. Yeah. So these are all oxyanions. Now, what are oxyanions, and is CO3 2 minus an oxyanion? What are oxyanions? As we said here, anions containing an atom of any element. So it has an atom of any element plus oxygen atoms. Okay. And is CO3 2 minus an oxyanion? Yes, it is. It has an element different than oxygen, and it's negatively charged. So let's take a look at the solution just to make sure. Yes, CO3 2 minus is an oxyanion. There you go. Okay, naming an oxyanion. So how do you name it? So we know CO3 2 minus is carbonate, right? Now, okay, how about NO3 minus? This is called nitrate. Now, how do we know how to name? Let's take a look. If there are 2, the one with the less number of O atoms gets the ending "ite," and the one with the more gets the ending "ate." If there are 4, the one with the least gets hypo, and the one with the most gets the prefix per and the ending "ate." So let me give you an example because this is very confusing. I have it written over here somewhere. Well, I remember writing it. طيب. Okay, I don't have it written, but I will give you I'll give you the example. Wait. So the first example I'm going to give you, and this is the one where you won't really see these in your exam a lot, but just, I'm explaining. So you have the most famous one is ClO, ClO2, sorry, ClO2 minus, and over here ClO is minus, Cl2O, sorry. What? Sorry, it's ClO. You have ClO, ClO2, ClO3, and ClO4. These are 4 different anions. The charge here is what? -2 and -1, so it's going to be, hold up. Yeah, so the charge of each one of these is minus. Okay, so that's not the point. The point is, how do I name these, right? So how do I name all these 4? Let's take a look. Following the rule, they said if there are 4, the one with the least number of oxygen atoms gets the prefix hypo and ending ite. So here it's going to be hypo chlorite according to this rule. Here the one with the most gets the prefix per and ending ate. So this is per, we just say chlor, and it ends with 8. Now the ones in the middle, what are they going to be? We said the one with the less number of oxygen atoms gets ite, so this is chlorite. And the one with the most is with an 8, so chlorate. This is just following the rules. So you start أول شيء with the ones in the middle, chlorite, chlorate, and then the ones with the least has hypo, the one with the most has per. Okay, not that hard. So as you can see here, ClO2 minus, it's called chlorite. Very easy. Chlorite or chlorate 3 ion. It's best over here. I see. In my opinion, it's best to say chlorate 3, because oxidation number of chlorine here is +3, right? If you can calculate it, how do you calculate oxidation number? Oxygen, each one is -2, so -2 times 2 is -4. So chlorine minus this 4 gets me -1, and you get that chlorine is equal to +3. So you can just say this is easier, صراحة. Chlorate 3 ion. Whatever, I don't care. I mean, this is hebel, like I really hate this stuff because I don't think it comes in any of the exams. What's the formula of nitrite or nitrate 3 ion? Type nitrate ion. Let's take a look. Nitrite, that means we have nitrogen, right? But since we're saying nitrite, that means we have less oxygen. Whoa, where'd that go? Come down. Okay, less oxygen. Yeah. Now, what do we know about the nitrogen ions? We know NO3 minus, it's called nitrate. So if this is called nitrate, then what will nitrite be? We know nitrite always has less oxygen than nitrate. So it's going to be one less oxygen, so NO2. Okay, now I know like it's not even making sense to me, but خلاص, go with the flow, bro. Another way, if you want to solve it, is they gave you the oxidation number is 3, so it's NOx, right? Minus, always it's minus. Okay, always oxyanions, most of them, for nitrogen and chlorine, they're always minus. So if this comes in your exam, how do you do it? If they told you nitrate 3, that means 3 minus 2x is equal to -1, right? Why is it -2? Because each oxygen is -2. So you get x is equal to 2. Yeah, you get x is equal to 2. So that means you have here NO2 minus. Okay, moving on. Naming ionic compounds with polyatomic ions. Special names of polyatomic ions must be memorized. So here, these ones, I'm gonna just leave this over here. The main ones you need to memorize. Most of them you already know them. This one you know it, ammonium. This one everyone knows. These ones خلاص إنه you're memorizing. CO3 everyone knows. Cyanide, this is actually poison. If anybody has seen the cyanide murders on Netflix. Anyways, SO4, SO3, خلاص you have these memorized. No, I can't really help you memorize, but these you never really see these. But these are the main ones, you know, these over here. These you need to know this. Okay, المهم. What is the name of MgClO4 2? So, as you can see here, it's an ionic compound, right? It's magnesium something, right? So, actually, we're going to just write down magnesium. Now, what is this ClO4 thing? What's this? Isn't this an oxyanion? Didn't we work with this? How do we name any oxyanion? Like we said, it's always the first one, and it ends with ITE or AT, right? Now, ClO4, اتفقنا, I gave this example earlier, is that it's called perchlorate, okay? And that's here in the table, so you need to know this. These chlorine ones, you need to know them, okay? So it's actually called perchlorate. So what's this gonna be called? What's this compound gonna be called? Magnesium diperchlorate. Now, someone might ask me, well, why is it di? Because you have this 2 here, okay? Let me just make sure if that's correct. Magnesium, oh no, You don't say di. Why am I saying di? Sorry. Magnesium perchlorate. Simply magnesium perchlorate. خلاص. Just magnesium perchlorate. Just magnesium perchlorate. مثلا when you have what's an example I can give? MgCl2. I don't say magnesium dichloride, I just say magnesium chloride. So same thing here, magnesium perchlorate. Okay, what is the formula of potassium thiocyanate? So potassium is K, thiocyanate. Thiocyanate is Cn, and I think you have, what was the thio? I forgot. What it was here somewhere. Yeah, thiocyanate S. Yeah, SCN. Okay, so SCN. So that's what thiocyanate is. So you have K and SCN. So what's it just gonna be? It's just gonna be K SCN. Very easy. So K SCN. Okay. Naming covalent compounds. So I think everyone knows how to name covalent compounds. Yeah, covalent compounds is when you use the prefixes. But remember, they say mono is never used for the first atom in the compound. So مثلا, if you have HCl, you don't say monohydrogen monochloride. No, you don't. You just say hydrogen chloride. In this case, it's hydrochloric acid. But anyways, so what's the name of NCl3? It's nitrogen trichloride. How do I know if it's covalent or ionic? Ionic is metal plus non-metal. Covalent is two non-metals. So what's the formula? So over here, like nitrogen and chlorine are both non-metals, so it's very obvious that it's going to be nitrogen trichloride. Okay, it's very obvious we're going to be covalent, and we're therefore going to use these prefixes. Okay, what's the formula of oxygen difluoride? Again, oxygen and difluoride means F2, right? So it's OF2. If I think it should be F2O. Oh no, I didn't know F2. Okay, naming acids. I think everyone knows how to name acids at this point. Oh, never mind. Okay, let's take a look. If an anion ends with IDE, the acid is given prefix hydro and suffix ic. So a very good example for this one. Oh, they gave an example here. HCl, the anion ends with IDE, right? So we say hydrochloric acid. If the anion ends with 8, the suffix ic is used. So مثلا, here the anion is what? Sulfate, right? So you're gonna use sulfuric acid. See how it's IC? There's no hydro. It's just, you don't say hydrosulfuric acid, you just say sulfuric acid. Okay, if the anion ends with ITE, then you say OUS. So مثلا SO3 is actually sulfite. So over here, we're gonna say sulfurous acid. Okay, over here. So when do you use OUS? If the anion ends with ITE. Now, someone might say, well, doesn't the anion here end with IDE? No, remember, what's this anion ClO4? It was in our table up, it's perchlorate. This is why I told you, memorize the chlorine ones, they're very important. This is perchlorate, and this is what here? Chlorate with an IT. Okay, so it's going to be called chlorous acid. Okay, المهم. Using the rules we learned, what is the name of H2S? What is the anion here? It's sulfide. It's sulfide ion. So this is just what rules do we have for IDE? We have here. You need to use hydro and ic. So if it's sulfide IDE, that means it's hydro. We have to use hydro, and we have to use the ic, sulfuric acid. What's the formula of hydrocyanic acid? Let's take a look. Hydrocyanic acid. We use the hydro and we use the IC. So what does that mean? It means it's going to be H, and since we use the hydro and we use the IC, that means the ion ends with IDE. Also, you don't need to use that. You don't have to know that it ends with IDE to solve this. Hydrocyanic acid. Hydro, H, cyanic, and it comes from cyanide, Cn. So HCN. Very simple. You just need to have the table up memorized. This is extremely important. Okay? Extremely important. Okay, so let's do this really quickly. perchloric acid. So أول شيء there's no hydro. So if there's no hydro, that means why did I bug, man? Sorry. Yeah, sorry. If there's no hydro, that means but if there's no hydro and you have the ick, that means you're using this third case here, and over here. What? If there's no hydro and if there's no hydro and you're ending with ick, you're using the second case. That means the anion ends with ATE. So over here, when you're saying perchloric acid, think to yourself: is there hydro? If there's no hydro, but you're using ick, that means it ends with ATE. ATE or ITE? ATE. Sorry, I'm a bit sleepy. Okay, so that means here, what is the anion we're using? It's going to be perchlorate, which is ClO4. What's the formula? Perchloric acid, HClO4. Anion name, perchlorate.
He's gonna talk me on my back. He's gonna kick me. What if you remove
Anion formula, ClO4 minus. So again, chloric acid. Here, no hydro. But you have the IC, so what does it mean? It's ending again with ATE. So what is it going to be here? Chlorate. Without the per. Without the per. So what does that mean? Is it going to be ClO4? No, it's going to be ClO3. Okay, so here it's going to be HClO3. Because you can't forget that we're working with acids, so there always has to be that hydrogen at the start. The anion name is just chlorate without the per. Ion formula ClO3 minus. Again, this comes from the table here. This 1, 2, 3, 4. They are extremely important. Okay, extremely important. Type moving on. Chlorous acid. There's no hydro and there's no ick. So what does it mean? It means I'm ending with IDE. Okay, if there's no hydro and there's no IC ick, it means your anion ends with IDE. So it's just gonna be chloride ion. Sorry, شو ID? I mean ITE. ITE. It's gonna be ITE. So chloros will become chlorite. How do I know? Again, since there's no hydro and there's no IC, that means it becomes that means it's ending with ITE, and therefore it's chlorite. So what's the formula of this? Hydrogen sorry, chlorite is what? Chlorite is ClO2 minus. How do I know? Again, from this table here. Okay. Okay. So therefore, the formula will be H, and then just copy this down. ClO2. Okay, what's the anion name? Again, chlorite. How do I know it's ite? Because there's no hydro and there's no ick. Okay. Anion formula will just be ClO2 minus. Okay, hypochlorous acid. Now, is there hydro here? No. Is there ick? No. So what does that mean? If there's no hydro and there's no ick, that means it ends with ITE. Type, since it ends with ITE, what is our what is it here? Hypochlorous. So since it needs to end with ITE, what's it gonna become? Hypochlorite. So what's it gonna be? What's the anion formula gonna be? Hypochlorite. What's hypochlorite? From the table, it's it's ClO minus. So what's the formula gonna be? HClO. Are these a pain in the ass? Definitely. I'm very sorry, but chemistry is chemistry. I hate it. You hate it. We all hate it. But you just gotta do it, bro. One more year till I get my degree. وخلاص. I'm never gonna touch chemistry again in my life, unless my children, for some reason, want to do chemistry. Please don't do chemistry if you're my child. Okay, المهم. Yeah, so this is the anion I told you. You have to get it from here. Okay, or you can memorize them. I don't care. Okay, given the following elements: neon, lithium, aluminium, chlorine, calcium, which of the following elements is most commonly found as a negatively charged ion? Okay, which of the following here is negatively charged? Now, neon is a noble gas. Okay, so obviously not. Lithium is group 1, so Li+. Aluminium is group 3, so 3+. Cl is Cl-, so calcium is 2+. So which one's negative? D. Which of the elements has the same electron structure as Mg2+? If it has the same electron structure as Mg2+, That means basically, and it has the same number of electrons. How many electrons does Mg2 plus have? If I'm not wrong, it's 10. I think it's 10. Let's just open the periodic table. Yeah, as you can see here, the atomic number is 12, so it has 12. So when it's Mg2 plus, it's going to be, whoa, when it's Mg2 plus, it's gonna be 10 electrons. So Mg2 plus has 10 electrons. Which one here has 10 electrons? If I'm not wrong, it's Al3 plus, and yeah, it is Al3 plus. You can check this in your periodic table. Why this becomes so big? Okay, that's weird. You can check it in your periodic table. Aluminum originally has 13, so when it's 3 plus, 13 minus 3, which is 10. So the same one that has the same number of electrons as Mg2 plus, so 10. Which one has 10 here? It's going to be C. And if I'm not wrong, calcium... No, way, calcium does. Okay, calcium is different. So it's aluminum, C. Which of the elements is found as a diatomic gas in its uncombined state? So which one is a diatomic gas? Obviously, it's none of the metals. So it's either neon or chlorine. But we know neon is a noble gas, so it can't be diatomic. It's always monatomic. So chlorine is the obvious answer, D. Aslan, you guys know chlorine exists as a diatomic gas, Cl2. So very easy. Question, let me just double check. DAD. DAD is definitely wrong. No way. Mg2 plus. Sorry. Of course, the answer here is neon. Why is it neon, ya Walid? Let me tell you why is it neon. It's neon because aluminum on its own, they didn't say Al3 plus. No, they said just aluminum. So what does that mean? Does that mean it has 10 electrons? No, here it has 13 electrons because they just said aluminum. Now neon, if you look at the periodic table now, see this, if I had the periodic table, I could have told you this. One second, let me show you. So if you take a look here at the periodic table, over here, you have, we're working with right now Mg2 plus. So when, we always know this rule that when you lose 2 electrons, you become the same electronic configuration as the noble gas beside you. Okay, so it's gonna be like what? Go back to 1, 2, you go to neon. So actually neon is correct. It has the same electron configuration. Okay, so it's neon. Okay, we're done with chapter 2. Thank you so much for watching and good luck.